electronics engineers. And what we do is we make projects. Anyone that has an idea, they can come over and build it. We make workshops. Though the name has like electronic engineers, we have all kinds of engineers as well, computer science majors. Can you guys comment what grade you're in if we have any guests here? Or if anyone wants to unmute and introduce themselves, go for it.
I can introduce myself. My name is Valentina. I'm a college student, and I'm the president of Expo. So happy to be here.
Welcome. Thank you for joining us. And anyone else?
I'll go too. My name is Alyssa. I am also a college student, and I am part of the corporate board of exhibitors for Expo.
Hi, Alyssa. All right. Thank you for being here.
Hey everyone, my name is Noah. I'm also a member of IEEE and here to help run and present as well.
Thank you. All right. Anyone else want to go? All right. We'll get started. I'll show you a little bit around our lab and what we do. And then I'll show you like a presentation for Arduinos and a little robots that we have, some interesting projects as well. Okay. Let me show you this. Great. It should. There we go. Can you see it? All right, this is Noah. Hey. He's our chair, IEEE chair, and over here is where we make our electric car, and we race it. We have two of them. I believe the first one's still under the making with some adjustments, and the second one's finished, I think. And over here we have all the trophies that we got from those races that I'm talking about. So we usually race one of these or both sometimes, and we're really good at it. So, and over here is where we have like our soldering station. So here's where we melt metal together. You can melt circuits, so you don't have to like remake the circuit every time. You can just have it permanently soldered together. And the tip, it gets really hot. I think it gets like 200 degrees Celsius. It gets really, really hot. Yeah, and this is like a fan for all the like fumes, so you don't have to like inhale any of it. And over here is where we have our VEX and Southeast Con robots made. So this one was last year's robot, and it was virtual, I believe, the competition for Southeast Con. And VEX is also where they give you like a bunch of guidelines and they have you compete with other schools, other universities, so on. And then over here is our robotics table, and we have like a few interesting tanks. I'll also be showing you some of those Lego cars on the table right there. One's line following. One's line following and one's obstacle avoidance, and then the third one I was gonna let one code it if you guys are interested. And yeah, okay, I'll show you the presentation. Oh, I forgot you guys can see my face. Okay. Oh, there we go. Share my screen again. Okay. Okay, so what we used for these Lego cars is something called a microcontroller, and it's over here. I don't know if you can see it, but yeah, and it's called this type's called an Arduino. So we'll talk a little bit about that, and then I'll show you how the cars work. So, like I said, it's a microcontroller, and it's used for a lot of things. You can make a lot of fun projects with it. And then you can make like a circuit that with just LEDs, like you can see on the left, or you can make like a little. Okay.
Is that bad? Do you have your sound off?
Oh, okay. Yeah.
Should be able to hear.
Okay.
It'll work from there.
Like all right. So yeah. Wait, let me go back. Okay, so it's they have a lot of resources online for Arduinos too. So if you're interested in like just getting started with like microcontrollers and learning a bit more about how to code or how to just use a microcontroller and make like fun circuits, they definitely have a lot of things online, and I highly recommend you check it out. So Arduinos are microcontrollers as well, and it acts like a small computer, so you can control like motors or sensors by connecting it to each pin on there, like I'll show you in a minute. So does anyone want to pitch in what Arduinos can be used for? Okay, or microcontrollers, sorry, not Arduinos. What they can be used for in general. Yeah, definitely programming robots. Yeah, awesome robotic hands. Were you working on that, Noah?
A long time ago.
Okay, and all right. Okay, yeah. So microcontrollers are used in a lot of places, basically everywhere. Phones, laptops, everything. So very interesting. So let's try it. Without further ado, I'm gonna. Wait, they can only see the slide. Okay.
Yeah, they can only see the slide.
What?
They can only see the slide.
Okay. I don't know.
You have to go back and share your whole screen if you want to do
Okay. Okay, so let me put this here. So, you're okay.
What are we doing?
We can do the line tracking. So it has like IR sensors at the bottom, senses the contrast. So it's gonna follow this black line over here, and here it goes. And it just like keeps adjusting, looking for it. That's like a little bit moving left and right. Oh.
Turn around?
It turned around by itself. Wait, I was. So yeah.
Sometimes it has a mind of its own. Why does it turn around on the side?
What's the difference between that camera and this?
I don't know. Is it too long loading? Is it trying to turn on?
It just goes out. Alright. Yeah, and another one is which one was the optical buttons?
That one. Or, well, hold on, I don't remember now. You moved them.
It was
Just
like
pick
that.
one.
Okay.
Nope.
Yeah.
No, that's not this one. Here, I'll fix it. There you go.
Hopefully these Lego cars will make it out of this alive.
Last year we played soccer with them.
Yeah, that was really fun. Like, remote control. Okay, so this one sends an ultrasonic wave from these little eyes. I shouldn't do that, but sends a ultrasonic wave from these little eyes, and then depending how long it takes to come back, it can tell if something is in front of it or not. So if it's far away, the wave will take longer to come back. And it's almost the speed of sound. So if anyone knows what that is, you can like go ahead and say or unmute your mic. Oh. So it won't go as long as my hand's in front of it. So. Oh.
It found that the only direction was back that way. You have to give it one way to go.
Okay, there we go. I just like bullying it. There we go. So, yeah, does anyone know what the speed of sound is?
It's like, don't know.
He's Googling it. Someone say it before. It's 343
3, yep.
meter per second, and speed of light is, who knows?
I know.
What?
Oh, Alyssa might know. Yes.
Yeah. Exactly. Oh man. Okay. And another fun thing I want to show. Can't see. Oh, okay. Beep. Okay, there we go. So, oh, does anyone have any questions about any of the robots? Okay. And you can like move the knobs. So this is a sound synthesizer. You can move them
Ooh.
or break the knobs.
Break the knobs.
You can gently move the knobs to change the sound.
Yo. That's awesome.
Sounds like a old video game. Thankfully, sounds don't sound like that.
This is how they actually did it, though. Like,
What?
that's how they actually made old video games. So,
Yeah, they did.
That's pretty cool.
Like a little. What old video game sounded like this? I don't know.
Like when you're in the Bowser's Castle or something from like Mario 64.
Yeah,
like
that's
some
true.
old retro stuff.
That's true. I don't know if anyone played Crash.
Crash? Yeah, I think I've heard Crash.
It's like an orange.
The orange guy?
Yeah.
Yes.
Yeah.
Valentina, yes.
So can you hear it? I don't know.
I don't know. Can y'all hear it from there? It's like very faint.
Not anymore, but we were a second
Okay.
ago.
Yeah, I think I turned it.
You can turn my volume
Yeah, we can hear that.
Okay, I'll stop.
down. The battery comes out.
All right.
It's fun though. You can definitely see the change.
Yeah. Okay. And this one, I just wanted to show it. It's a 555 timer. You can actually make a synthesizer with this, but I didn't have one. This is an enlarged version of it. So you can see like you have little resistors and you have all these like components, transistors, and it can be
Big
small.
555.
Yeah, it's
That's
not
huge.
actually like practical, it's just like a display. But it can be as small as like this small. Like,
Oh, there's one on here.
okay. Yeah. So it can be as small as like something like this. All right. Yeah, it can be as small as something like this over here, just this part. So that's pretty interesting. Like you have all these things that can be fit onto, and like even the synthesizer, like all this stuff now just like fits on your video game or like your phone. So so yeah, what else did I want to have? Also had like a really thing, but I don't think it works. Wireless. Like a wireless charger. But yeah, it used to work. But
Yo, you made your own wireless charger? That's dope.
yeah, so like you basically how your iPhone charging works. Some people have like wireless charging toothbrushes. I don't have one of those. I wish. Do you?
No. My
But
phone does it.
yeah. Yeah, so like phones, basically there's like a little winding of coils at the back. And then when you bring them close together, there's like an electromagnetic field inside. Because of the current going through it. And it just like lights up it just lights up the LED, but it got detached. But yeah, very interesting. So like your charger would have one of these, and then your phone would have one, and then put them on top of each other, and your phone starts charging. So it's pretty fun. And I also made like a little Kahoot. I was gonna. Some of you have already played it, but oh, that's so cool. I actually have a presentation about it, but I don't know. I'll present it. Let me see. Okay, yeah. So wireless charging.
Oh, you have a whole.
Yeah. So we have it in phones, cars, toothbrushes, and like. Yeah, that's it. Maybe in the future, who knows? So anyone, I already told you how it works, but if you wanna, how did you think it worked before? Like, how did you think? Were you like, oh, I just put my phone and it magically starts charging because of touching things? Okay. Did anyone comment?
I did.
Okay, so yeah, like I said, okay, but Yeah, there's like an electromagnetic charge, and then there's a the two when you bring in the two coils close together. One of them, the LED can light up or your phone. So it's called inductive charging. And yeah, if you have any questions, I just share the code.
You're only sharing in PowerPoint.
What?
You're only sharing in PowerPoint if you were trying to do something else.
I was about to open the Kahoot. Background music, thank you.
It's the Jeopardy music. There we go.
Okay, so Noah, join.
Okay, hold on. How do we do this again?
So
you visit kahoot.it.com
yeah, and then put in a pin.
or no, not even .com. Just .it.
Yeah, and then 592
592
4599.
4599. Alrighty. I haven't played this yet. That's Noah. Let's see. Who else is gonna join? Okay, well, do we have the Kahoot background music?
Oh.
Does it sound Oh.
All right. Journey. Oh.
Valentina's here. Journey's here.
Ryan.
With the face emoji. I like it. I can never figure out how to do those for some reason. Huck. Cool.
You can put like a sideways happy face.
Oh, yeah. Yee.
Alyssa.
Yee and Alyssa. And I think that's 8. I think that's what we have on the call right
Brooks.
now. Yeah, we got 8 on the call right now, too.
Oh, really?
All right. Yeah, we got 8
Great.
people. We got 8 on the call. Awesome.
Okay. I'm going to start. Okay. I can't hear the music, but I don't know.
I'll turn my sound off on here again.
Oh, like it's going on.
Okay, go for it. Say it again.
Which of the... What?
Say what you...
Oh, which of the following is not a programming language?
Can't actually see them.
All right, yeah. Great job. That is correct. I just made that name up, so.
There's something called TypeScript, though.
Oh, well.
All of the above.
Which of the following we use to move a Lego car?
What's an FPGA, Rana?
Field programmable gate array.
Whoa.
And you can use it to make like logic gates and connect instead of like connecting everything on the breadboard, like here. You can
So
just
much
have,
easier.
Yeah, you can just have a FPGA and connect them there instead of all the wiring. So, very interesting. Yes, that is correct. It's an Arduino. Rex is in the lead. 3D printing can be as small as, so not specifically our 3D printer, but like in general, how small can a 3D printing print be? Coin, a pencil's tip, an ant's forehead. What do you mean? Don't. Yeah, it can be as small as an ant's forehead. So, pretty small. Pretty small.
Oh, Brooks, I'm coming for you. And I've never played this before, so.
Sunsets on Mars appears. Today was the rover launch.
Landing.
Landing.
It launched in July.
Oh my god. Yeah, the landing. I missed it, but he watched it, so how do sunsets on Mars appear?
Honestly, I have no idea.
Give a guess.
Blue. What?
Yeah. So it's like the opposite of Earth during the day.
Seriously?
It's like red. It looks red or orange, and then like on sunset, the sunset looks blue.
That's
So,
awesome.
Yeah.
I need to look that up.
He doesn't trust my Kahoot.
No, but like, why?
Okay, this
Multi-select.
one is just what was your favorite part of the exhibit?
Oh, if all these answers are right.
So
Oh,
I
we
didn't.
didn't
Yeah, I did
Into the orb.
The orb. I needed to like turn off the light, but
Oh, I can add a light if you want.
okay.
You want to get the orb plugged in?
Sure. Yeah, I put batteries in it. Yeah, thank you. Okay. So this is. Can you see it? Maybe I should.
Stop sharing.
Or turn down my brightness too.
Oh, I won. Oh, I wasn't supposed to win.
What?
Noah!
Noah!
My bad.
Oh, they can see it really good.
Oh, that's awesome. There you go.
It's really bright. Look at that. And I'm not getting electrocuted, so.
If I poke it. Ah!
Okay. Okay, yeah. Yeah, I love it too. I was blown away as well. Valentina. So, hello, I see who just joined us. Welcome. So yeah, that is the end of the exhibit, but I can show it like for the two people that came, I can like show you things again.
Oh, did you show them the octopus that we have?
Oh yeah, show them. So someone was it Hunter?
Hunter, yeah.
He 3D printed this octopus with our 3D printer. So that's pretty fun. Yeah, it looks pretty cool.
That's awesome.
Thank you. So, yeah, it's really nice. I like octopus. They're cool. I like octopi. They're really great animals.
Yeah. So I have a question. Like, how long does it take to build the complete octopus in 3D printing? How long does it take, like, to
Build the
complete
what?
the full octopus model?
Oh, I don't know, but it probably took
6 hours, 4 or 5 hours.
so like 4 or 5 hours.
Oh, wow.
Depends on the printer you have.
Okay, thank you.
No problem. I feel like it's so long. But yeah, thank you for stopping by. If you just joined us, you can stay behind. I can show you some things again.
Any questions or comments or concerns?
Yeah.
Or you enjoyed it? You didn't enjoy it? Things we could do better?
Thank you, Valentina. Thank you for stopping by again. It's always nice to have you. And thank you for arranging it. It was really fun.
Thanks. Did you show them the video that you made?
The video. It's on their. It's on their.
Oh,
website.
it's on the on-demand stuff?
Yeah. It's on their website.
So go check out the on-demand stuff if you haven't.
Yeah. Oh, okay. I'll go grab one. Thanks.
Oh, okay, fine.
Did you get one? Why?
I didn't realize I didn't put two together.
Okay, yeah, I'm there. I'll go grab one. Thank you, Alyssa. Talk to you later. Okay. So for those people that are here, I'm assuming you want to see things, right? Again.
Was here before.
Or new people, right? Or no? Or like.
No, Alyssa was here before. MP was here before. Or Sebastian. Was Sebastian here before?
I think so.
Is anybody here not seeing the presentation that we have? Jessica, possibly?
I think.
Jessica is typing. Dun, dun, dun. Hi, Heaven. Awesome. Okay, so Jessica wants to see it.
Oh, okay. Sure thing.
I think we can go ahead and
I think there's another person.
rewind this.
Norma. Oh, she left. Oh, the rest not visible. All right. So I was gonna show you the lab first.
Me dodging everything.
Have motion sickness.
Oh, here's the mic.
Oh.
I'll follow you around. You want me to hold the camera? There you
If you have like motion sickness, how does this happen?
go. You got caught in this. We just installed these.
Oh, interesting.
Yeah. There you go. You want me to hold something?
I think I got it. Yeah, there we go.
Oh, it
No.
doesn't sit?
I think you need to like close it so that. There we go.
There you go.
All
That'll
right.
work.
Okay. So over here we have our electric car racing card. So
It's this big. I'm a 6 foot tall and it's a big car.
yeah, and so like a human fits in there, right? So someone drives it and we race it around Tampa and around Florida too. So we have all these trophies from that. It's really fast. What's the fastest it can go?
Like 40 miles an hour.
Oh.
Maybe 50.
Oh, wow.
I pushed it to 35 myself, but that was around a small track. But
Okay.
like long straightaways, you can get like
30.
you can hit like 40 close to.
Okay. And this is our soldering station. This is where we solder things together, so it's not like stick pieces together, but like in metal. In terms, you can like use this to melt metal together with the solder, so that like because you don't have to keep remaking your circuit, or you can even make little connections on your PCB board. And over here we have Vex and SoutheastCon competition robots. So at the top is our old SoutheastCon robot, and they basically give you a bunch of guidelines and tell you what conditions need to be satisfied, and you just make a robot based on that. So it's really fun. Last year was virtual for Southeast Town, and Vex we're doing it for the first time this year. So this is a robotics table. We have little tanks. And also I'll be showing you the Lego cars over there. And
That was a good pointing, honestly. I'm impressed.
And over there,
Just walk over here.
let's just walk. And over there, there's the 3D printer, and someone 3D printed this octopus, which is really cool. And we have, how hot does it melt? The
200 degrees.
Yeah, Celsius.
Celsius? Yeah.
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 And and I'm gonna show you a little bit about
It's the one that's gonna drive.
Arduinos. Does anyone know what an Arduino is? Well, the people that I haven't just told. Yeah. Like, almost dropped everything on the floor.
So that's this guy, right? This right here is called an ultrasonic sensor. And what it does is it sends out sound waves and waits for a response back, and it takes the time that between its signal and the signal coming back to measure where there's an object. So if it sees an object, it doesn't go that direction. So when I turn it on, it's looking and it says, hey, my hand's there. So I'm going to turn that way. And it doesn't go that way. And so it just keeps dodging until it finds somewhere there it can go.
And then we have the line tracking robot.
This one?
No. The one with the tape is
That's the wrong one.
It is.
There you go.
So there it is. It's gonna turn. I believe in it. So it keeps following the line. So anytime it keeps moving like left and right because it's looking for the line. So anytime it doesn't see it, it'll like readjust and move right, or like readjust and move left. That's why it's like a little. There you go. Oh.
Sometimes it likes to go down off the cliff.
Yeah, and they're both made with Arduinos. So over here, this one, you can see this is an Arduino, and they're connected to like the motors, to the sensors, and all that, and you can easily code it to do whatever you want. Yeah. Over here, wait. So this one. No, it's not. Make sure you connect it. Okay, so when you turn the knobs, it'll like change the sound. And this is like the little speaker. Your headphones are working, it just sounds like an old video game.
What's the top wheel for?
Which top wheel?
Oh, on the car? No, the top wheel is just a spare tire.
Oh.
It's just being set there for storage now.
Is there any other question? I haven't really looked at it.
No.
Okay, so when you turn the knobs, it'll like change the sound. It sounds like an old video game. Oh, that's that. I'll turn it off now. You can also hear headache. So here's that. And yeah, for this one, I made like an electric charger that is the assembled right now. But basically, when you had this is the full second, so let's go here. Stop this one. Go here. Yeah, so one will go here, one will go here. When you bring them closer together, the LED would light up over here. This one. And how it works, so you're sending like the current through the wires, and that makes a electromagnetic waves through both of them, which causes it to charge. It's called inductive charging. And do you want to finish that?
This is a 555 timer. I'm not really sure what I'm supposed to be showing.
Just show them
I'll get to Ron. Usually, they're very tiny. They can go all the way down to, you can see this little black chip size. But this is a large version for educational purposes, which I really want to see the breadboard for. Like, do they have a breadboard this size? And you have like a big puzzle board?
No, I don't think this is functional. It's just like for
I think
display.
Because it's got, well, maybe not. It looks soldered like it would be. I kind of want to test it out.
Like, put it here. Here's the battery.
But it's used to make like timers or alarm clocks.
And it can make a synthesizer like the one I just showed you.
True. Yeah.
Just with a 555 timer. And
cool.
Yeah. And that's
about it, right?
it. Yeah.
Any other questions, comments?
I really have questions.
You realize it comes on? Such a cool you guys. Yes, we do. You should come join us. Are you at USF or are you a student? So you're USF.
Are you a USF student or not?
Industrial, right? It says on your contact card. Well, you can still join us anyway. We have other we have several majors.
Yeah.
You just don't have to be electrical. We have computer science, mechanical engineering. Graduating in May though. Oh well, good luck to you. You can still join us until then if you want.
Thank you for joining us today. Any other questions, or you can just unmute your mic, say anything, say hi. You have it. Okay, that's the end of the exhibit. Thank you for stopping by, and for those who watched it a second time. So, yeah.
That's all for now. Noah's out. Thank you for joining. We have there's another section of Biomedical Engineering Society.
All right.
They can help save your life, maybe. Thank you, Valentina. Where is the lab located? It's in the engineering building, on the first floor, E&B 149, I think.
Yeah.
Okay, thanks. Yeah. Anytime. Have a great rest of your day. And this has been it. The Noah and Rana IEEE exhibit.
Bye.
Thank you, guys. It was fun.
No problem. Thank you for coming.